Start recording. Option is already enabled, but it is not showing red color here. Okay, it is showing now. Okay, so listen. So first we are going to see about a rectifier. As Kishan said, the rectifier is mainly used to convert AC into the DC. Okay, already I told you the AC is nothing but a alternating current. Alternating current ka you can take an example sine waveform. So here the voltage is not a constant one. Okay, here it is going to vary with respect to the time. That is an alternating current. So in our home, generally the current coming to our home is here 230. From the transformer, we are getting here near to 230 volt AC value. Okay. So for our mobiles and all, it need only a small voltage. That is, you know that if it is of PN junction diode, we have to apply a small voltage like 0.7 volt only. Okay. So what we are going to do using a rectifier, we are going to convert that high AC voltage into the DC voltage. Okay. So the DC voltage is nothing but we will get some constant value with respect to the time. Okay, it is not going to vary with respect to time. We will get some constant voltage. Like for example, if you want 6.2 volt means we will get the 6.2 volt here. Okay, so the main thing about the rectifier is nothing but here it is mainly used to convert AC to DC. Okay, so the process of converting that AC into DC is called as the rectification. The circuit which we are using for the rectification is called as the rectifier. Okay, so first we are going to see about a rectifier. Rectifier में different types है. One is nothing but a off way rectifier. Next one is nothing but a full way rectifier. Then this full way rectifier is further classified into the center tapped and bridge rectifier. Main important thing is in this you need to in the university exam they will ask questions from the rectifier. At least they will ask one questions from the rectifier. They will ask you to explain the rectifier, any one of the rectifier. Either they can ask off way rectifier or they will ask center tapped full way rectifier or bridge rectifier. Okay, it is very important one. So the next topic, already I told you rectifier matlab we are going to convert AC to the DC. So next we are going to see about a clipper and clamper. Clipper and clamper means the clipper, what is the general meaning of clip? Clipping is nothing but we are going to remove. That is nothing but a clipper. Okay. So suppose if you are having some AC voltage means in that AC voltage, suppose you want to remove the particular positive side of the waveform means we are going for the clipper. What is the meaning of clipper is nothing but using a clipper circuit, you can remove the particular portion of the waveform, either positive side or negative side. In this clipper also we are going to see about a bias with biasing how we can remove the particular portion from the waveform. Okay, so that is nothing but a clipper. Generally the clipper is nothing but we are going to remove the particular portion of the waveform. That is nothing but a clipper. Next we are going to see about a clamper. What is the use of the clamper is we are going to shift the waveform to the high voltage level. That is nothing but a clamper. Okay, for example, this is your input waveform means I want to shift my input waveform to the some other voltage level means so I can go for the clamper circuit. That means clamper circuit means I am going to shift my DC value to the either above and below the axis. Okay, axis is nothing but yeah that x-axis time we are considering, right? So using a clamper circuit, you can shift the waveform above and below the axis. Okay. Then we are going to see about a voltage multiplier, how to increase the voltage value. Then already you know about a Zener diode. I already told you the application of Zener diode is voltage regulator. Okay. So using a Zener diode during the reverse bias condition, we can provide the voltage, constant voltage. Okay. So later on we will see about a Zener diode as a voltage regulator. After that we are going to see about a special diode such as LED, tunnel diode and LCD. Okay, you know about a LED light, right? On and off and all. Okay, so we are going to see about a special diode in unit 2. Okay, so first topic I am going to teach is rectifier topic. Okay, so hereafter I will use this pen tablet method to explain the concept. Okay. So shall I start the topic rectifier? So first topic in unit 2 is I am going to teach you the rectifier. Okay. Already I told you what is the meaning of rectifier. Suppose if you are having a copy, that is a register and pen, please note it down parallelly with me. Okay, so already I told you what is rectifier. Rectifier ka use kya hai? The rectifier is mainly used to convert AC into the DC. Okay, AC into the DC voltage. Okay, so what is the meaning of rectification? You know, the rectification is nothing but the process of converting AC voltage into DC voltage. That is nothing but the process of converting AC into DC is called as the rectification. Okay, is called as the rectification. Okay, the method, okay, the circuit which we are using, I already told you, in a rectifier we are going for the full wave rectifier, half wave rectifiers and all. So full wave rectifier, half wave rectifier matlab आप एक particular circuit use करने पड़ेगा, right? So here we are going to use the circuit, okay, the circuit used to perform the rectification, the circuit used to perform the rectification is called as the perform rectification is called as the rectifier. Okay, the circuit which we are using to perform the rectification. Rectification matlab kya hai? You have to convert AC into DC. That is called as the rectifier. So please note it down. What are the different types of rectifier? Okay, so the rectifier we are having a two type. One is nothing but a off wave rectifier. Okay, one is nothing but off wave rectifier. Second one is nothing but a full wave rectifier. Okay, so again one is full wave rectifier. This full wave rectifier we are going to see about here two method. One is nothing but a center tapped. Okay, later on I will explain you what is the meaning of center tap. Next one is nothing but a bridge rectifier. Okay, that is bridge full wave rectifier. Okay, so these are the classification we will see one by one. I already told you this is very important one. So most of the time they will ask you to explain the full wave rectifier. Okay, in the university exam you just refer the previous year question paper. Each and every year at least one question they will ask from the rectifier. Okay, so first today I am going to teach you the off wave rectifier. Okay, today I am going to teach you the off wave rectifier. Okay, off wave rectifier. So already I told you very simple concept only. You know about your diode already. Okay, so what is the meaning of diode? During forward bias, the diode will act as a short circuit. Short circuit matlab diode will be on condition. During reverse bias, the diode will act as a open circuit. That means there is no flow of a current. So same principle only we are going to use here also. Okay, so first I will draw you the diagram of the off wave rectifier. So already I told you here I am going to what is the input for the rectifier is AC. Okay, already I told you the rectifier is nothing but mainly used to convert AC into DC. Okay, so the input for rectifier is nothing but a AC voltage only. Okay, so I am not already you know that if you are connecting to the any plug point, we will get the voltage near to the 220 to 230 volt. Okay, so if I apply this 220 to 230 volt directly with the diode, what will happen? आपका diode burn हो जाएंगी क्योंकि already I told you that each and every electronic component can withstand only the particular small voltage only. For example, if it is of PN junction diode means you know that when your applied voltage is equal to zero 0.6 volt or 0.7 volt, there will be a sudden increases in the current. Suppose if you apply 230 volt, what will happen? Directly if you apply 230 volt directly to the diode, आपका diode burn हो जाएंगी. You know that if you are having a laptop, we are not going to connect our laptop directly with the 230 volt. We are using a adapter, right? That adapter what it will do? That adapter convert the 230 volt into the smaller voltage of how much voltage your laptop required. Okay, so that's why we are using adapters and all. We are not directly you can use some wire. Okay, just to connect wire from plug point to your laptop, what will happen? Your laptop will get burnt. Okay, इसलिए क्या करने पड़ेगा? You have to reduce the voltage. Okay, so voltage reduce करने के लिए here I am going to use a transformer. Okay, here I am going to use one transformer. You know the transformer has the two winding. One is the primary winding and secondary winding. Here I am going to use the step down transformer. What is the meaning of step down is Generally there are two type of transformer is there. One is step up, another one is step down. What is the meaning of step down is nothing but it will decrease the voltage level. For the transformer, I am going to apply the 230 volt means this step down transformer is designed to provide only the 6 volt. Okay, so please listen carefully. This is here transformer. Why I am using a transformer here? Kyunki okay, so it is not possible to apply the 230 volt directly to the diode. Suppose आप 230 volt directly diode का apply करेंगी means what will happen, diode आपका burn हो जाएंगी. So इसलिए क्या करने पड़ेगा, voltage level आप reduce करने पड़ेगा. In order to reduce the voltage, we are going for the transformer. The name of the transformer here I am using a step down transformer. Step down transformer matlab it will reduce the voltage level. Okay, so after this already I told you we are seeing the application of diode. Okay, so we are using the application of diode. Here I am getting the here I am using a diode. Okay, PN junction diode I am using, and here I am going to use one load. Okay, so here I am going to use one load. Okay, here I am going to use one load. Okay, that is nothing but a RL. Okay, this is the circuit of the off-way rectifier. Okay, please listen carefully. Just you have to first apply the input voltage. The input voltage for off-way rectifier is the AC voltage. After that, we are not going to apply this directly 230 volt to diode. आप क्या करने पड़ेगा? एक transformer use करने पड़ेगा. What is the function of this transformer is? It is a step down transformer. It will reduce the voltage level to the 6 volt. Okay. Then I have used one diode, and then it is connected to the load resistance. From the load resistance, I am going to measure my output voltage. Okay.
मैम और जो वोल्टेज रिड्यूस करेगा वो 6 वोल्ट तक ही करेगा या उससे भी कम कर सकते हैं?
हाँ. No, that is depends upon that what type of winding they are using. Okay, here I am considering that this transformer can give only 6 volt. Okay, it will reduce the 230 volt to 6 volt DC. Okay, okay, Kishan?
Yes, ma'am.
Okay, so now I will explain you the operation of the off-way rectifier. Okay, so already I told you the off-way rectifier consists of three important components. What are they? It has here transformer. The transformer is followed by a diode, and we are having a load resistance. Okay, so these are the three important component of the off-way rectifier. So what is the meaning of off-way rectifier? You have to know. This off-way rectifier provides the output for the off cycle of the input waveform. Suppose if I am applying the full input value here means, that is here I am applying the full input values. Okay, the full input value means full cycle I am applying, positive as well as the negative of cycle. Okay, so if I apply this positive and negative of cycle to this rectifier circuit, off-way rectifier circuit, this off-way rectifier circuit only gives the positive of cycle only. Okay, it will gives only the off cycle. Okay, so now I will explain you the working of this off-way rectifier circuit. Okay, now I will explain you the working of off-way rectifier circuit. Okay, so first I am going, already I told you the input for the off-way rectifier is a sine waveform. That is, I am going to apply a AC signal only. So in the output, I should get the DC value. Okay, so first I am going to consider the operation of off-way rectifier during positive off cycle. Okay, so during positive off cycle, so you know that this is my transformer. Okay, if it is of positive off cycle means here I am going to apply the positive voltage here. Okay, that means here I am going to apply the 30 volt. I am going to consider during positive off cycle what output I am getting. Okay, so please tell me. Okay, this is my diode. If I apply the positive voltage here, what is the condition of the diode? Diode is either in forward bias or reverse bias. Tell me, beta. Here I am going to apply the positive. You know what is the meaning of forward biasing? Forward biasing means what? The positive terminal of the battery or the positive is applied to the anode means diode will act as a forward bias. Okay. So now the diode will act as the forward bias. So what I can do? I can replace this diode by a, if it is a forward bias means what? There is a current flow. Okay. If it is a forward biasing means it is a short circuited. So the diode is the short circuiter. So there will be a current flow in the circuit. So if I am going to measure my output voltage during the positive off cycle, here I am applying the input as a positive off. So during the positive off of the input cycle, the output also I will get the same thing only. That is, the output is equal to input. It is a short circuit, so the output voltage is equal to input voltage means, so here the output is positive off value I will get. Okay, so this is my positive off value. So the main thing is during the positive off cycle of the input voltage, so diode is act as the forward bias kyunki the positive of cycle is connected to the anode. So positive means the diode will act as a forward biasing. So if it is a forward biasing means there will be a current flow. Okay, there will be a current flow. That means the output is equal to input. Okay, so for this period of interval, the output is equal to input. Okay, so here I will get the output like this. Okay, so next I will explain you the operation of negative off cycle. Ayushi, please mute your mic. Okay, so during negative off cycle, suppose if I apply the negative off of the input to the my rectifier circuit, of a rectifier circuit. Now I am going to apply a very simple operation only. You know that if I apply the negative off means the input for diode is nothing but a minus. Here it is of a plus. Okay, so you know that if the diode is connected to the negative terminal, the anode of the diode is connected to the negative terminal means what will happen? The diode will act as a reverse bias. Reverse bias means what? The circuit is that is the diode will act as a open circuit. Okay, so diode will act as a open circuit, so there is no current flow here. Okay, there is no current flow here. I am going to measure my voltage. So if the diode is if the circuit is open circuit means there is no flow of current, so the output is equal to 0 volt. Okay, that means for example here this is my I will draw the waveform. Okay, this is my input signal. Okay, this is my input signal. Okay, so this is my input. So here I am considering it is 0, pi, 2 pi. Here I am considering the interval. This is 0, pi and 2 pi. Okay, so what is the output I will get is during the positive of cycle. During the positive of cycle, diode will act as the forward biasing. Diode will act as the forward bias. Okay, if diode is act as a forward bias means it is the closed circuit. So during this interval, if it is a closed circuit means there will be a current flow in the circuit. That means output is equal to input. So here you will get the waveform. During negative off cycle क्या हुआ? आपका diode will act as a reverse bias. Reverse bias means it will act as the open circuit. So there will be no current flow. So during negative off cycle, you won't get any output. Similarly, again during positive off cycle, your diode will act as a forward bias. You will get the output waveform. So here you will get the value. Okay. So 0 during positive off cycle, you will get the waveform. During negative off cycle, you won't get any values here. Okay, so this is the operation of the off-way rectifier. But you can ask me, ma'am, you said the rectifier is a circuit mainly used to convert AC into DC. If it is of DC, we should get the straight line only, but here we are getting a AC waveform. Okay, so the main thing is, in the rectifier output, we are not only getting the DC, some of the AC components are already, some of the AC component is added with the output. Okay, so how we can estimate that how much AC component is added in the circuit, how much DC component we are getting? Actually, in your syllabus, you are not having another one circuit. Okay, you are just studying about a off-way rectifier, full-way rectifier. But we are having another one circuit, that is off-way rectifier with capacitor. Okay, so in this output, if I use one capacitor, this capacitor will provide a proper DC value. In order to get DC value, here I have to use one capacitance in order to get the pure DC. Okay, but in your syllabus it is not there, so that's why I am not going to explain you. So in a rectifier, whatever the output we are getting, this is not a pure DC. Some of the AC component also added with our output. Okay, समझ आया बेटा? Hello, is it clear the working of off-way rectifier?
Yes, ma'am.
Okay, so listen. Already I told you this rectifier circuit is very important topic. Okay, So how they will give mark only for this working? Okay, they won't give you the mark. Actually, in the off wave rectifier and full wave rectifier, you have to derive the some parameter. Okay, what parameter you have to derive is in order to perform the analysis of off wave rectifier. Already I told you, off wave rectifier may you are not getting a pure DC. Okay, so what you need to do in order to analyze this, that is you have to do some analysis how much AC component and DC components are there in your circuit. Okay, so for that, we are going for the analysis. In the analysis, we are going to measure some parameters. Okay, that is very, very important one. In a 10-mark question, you have to explain everything. Okay, that is you have to explain your parameters. Some of the parameters to analyze the off-wave rectifier. This parameter is very, very important one. Okay, so next we are going to see about the analysis of off-wave rectifier. Okay, anyone tell me if it is of AC signal, how it is represented in the mathematical form? Any idea? If it is of sinusoidal signal, how we can represent in mathematical form? So you know that signal means what? This is my AC signal. Signal means sine waveform or cosine waveform. Anyone know how to represent the signal in mathematical expression? Any idea, beta?
M sin n pi.
Okay. Sine omega. Okay. Sine pi, sine theta. Okay. Very good. Very good. Okay. So, generally for this analysis, I am going to write some mathematical expression for this waveform. Okay. So, generally here the input voltages, that is the voltage which I am given to the circuit is nothing but a AC signal. Input applied to the circuit is nothing but a AC signal. Here I am considering it is a sine waveform. Okay, you know that sine waveform means sine 0, you will get 0 only. Okay, so if it is of any AC signal in a mathematical expression, I can write it as VI equal to Vm into sine omega t. Anyone tell me what is the meaning of Vm? Vm मतलब क्या है?
Maximum voltage.
Okay, maximum voltage. So already I told you this is the AC signal. Here the x-axis is nothing but your time. Okay, the y-axis is nothing but your amplitude. That amplitude is nothing but your Vm. Okay, generally if it is of signal means signal का कुछ characteristics है. क्या क्या characteristics? Amplitude. Amplitude मतलब height of the signal. Similarly, the width is nothing but your time. Then we can represent your phase also, but we are not going to consider phase here. Sir, I am going to consider the amplitude and time of the signal. Okay, so how I can represent my input voltage is Vi equal to Vm. Vm is nothing but the amplitude of the sine waveform. The Vi is nothing but the amplitude of the sine waveform. Okay, amplitude of the sine waveform. The sine omega t is nothing. Omega is nothing but the angular frequency. The t is nothing but a time t. Okay, so from this expression, I can write the values. That is, this is my input signal. This is my input signal. Okay, so I'll write to you here. You consider that this is your pi. Okay, this is 0, pi, and the full cycle is of your length 2 pi. Okay, so 0, pi, 2 pi. Okay, so for my output waveform is this is my output waveform. During positive of cycle, I will get it. So output is 0 to pi. So pi to 2 pi, there is no value, that is 0. Okay, so how I can represent my output voltages? This is the input voltage. Okay, how I can represent my output voltages? Okay, so the output voltages, that is, I can write it as V naught or VL. VL is equal to, why VL? Because I am measuring that output voltage across the load resistance. So VL equal to Vm into sine omega t. So here we are getting a output value between 0 to pi. Okay, when your omega t is value is equal to 0 to pi means you are getting a sine waveform. You are getting a sine waveform. From pi to 2 pi, आपका output क्या है? From pi to 2 pi, आपका output is 0. That is pi less than or equal to omega t less than or equal to 2 pi. Here there is no output. So इसलिए आपका value 0 है. ठीक है? So in this way I can write my input and output. Okay, so output for the input I can write the range from 0 to 2 pi. But for the output, so here I am getting the sine waveform during the interval 0 to pi. From pi to 2 pi, there is no output, isliye 0. So now I can write my current value also, the current across the load resistance. Okay, that is IL equal to Im into sine omega t. Its value also between omega t less than or equal to pi, 0 otherwise. That is not otherwise. This is from pi less than or equal to omega t less than or equal to 2 pi. Okay. So this is main important thing in the exam. You have to draw the waveform also. This is a waveform of the off-way rectifier. Okay, this is a waveform of the off-way rectifier. So now what are the parameters we are going to measure is, first I am going to measure the AC load current. Okay, first I am going to measure the first I will measure the DC current. Okay, that is DC, or I can call it as the average load current. Okay, average load DC load current. Okay, I am going to measure. Already I told you rectifiers convert AC into DC. Okay, AC into DC means here I am going to measure that how much DC component we are getting in the output. Okay, so in order to measure the DC component, the formula I am going to use is IDC equal to 1 by 2 pi integral of 0 to 2 pi. Okay, 0 to 2 pi, generally IL into D of omega t. Okay, so now I am going to measure the DC current. Okay, DC current. So DC current measure करने के लिए क्या formula use करने पड़ेगा? Generally 1 by 2 pi into integral of 0 to 2 pi. Okay, IL into D of omega t. Already I told you what is the value of IL. IL आपका मालूम है. IL is nothing but IL is equal to Im sin omega t. Interval is 0 less than or equal to omega t less than or equal to pi. 0 otherwise. Okay, अभी आप क्या करने पड़ेगा? Just substitute the value of IL in this equation number 1. So आपका मिलेगी 1 by 2 pi. Okay, so the 0 to pi, your value is Im sin omega t, 0 otherwise. So आप क्या consider करने पड़ेगा? 0 to pi. So here my current value is Im sin omega t, d of omega t. Okay, plus from otherwise, not otherwise actually, if it is of otherwise means all the interval we will get 0. Okay, so from the pi to 2 pi, here my value is 0. So 0 into d of omega t. So 0 into anything, 0 ho jayegi. So you will get 1 by 2 pi integral 0 to pi Im into sin omega t d of omega t. Okay, so अभी क्या करने पड़ेगा? You know the integration, right? बेटा आप लोग का integration मालूम है ना? Okay, anyone tell me what is the integration of sin omega t?
minus cos omega t by omega.
Okay. So you know that. Okay. So the integration of sin omega t is nothing but minus cos omega t. Okay. So here the Im is a constant. So just I am taking that value here. So here if I perform the integration means I will get the value of minus cos omega t. Okay. Then the interval is 0 to pi. Okay. Well, then the interval is 0 to pi. Okay, just substitute the value upper, you know that how to substitute the limit, that is upper limit minus lower limit substitute karne padega. So Im by 2 pi into, just substitute the upper limit cos pi minus, so already here minus is there, minus of cos 0. Okay, so what is the value of cos pi is? So here the cos pi is equal to 1. Okay, so you know that cos 0 is equal to 1. So here I will get Im by 2 pi. Im by 2 pi. Sorry, cos pi value is minus 1. So minus of minus 1 minus minus of 1. Okay, so minus into minus will become plus. So you will get 1 plus 1, you will get 2. So Im by pi you will get. Yes, beta?
मैडम
हाँ जी बेटा.
cos omega t by omega आएगा ना माइनस जो लिखा आपने इंटीग्रेशन करने पे?
No, here you, what is the value of cos theta? Cos theta का integration क्या है? What is the cos theta का integration क्या है? Sorry, sin theta का integration क्या है? That is minus cos theta. Okay. Here we are, don't think that here we are not integrating this value with dt. We are integrating this value with d omega t. So here you consider d omega t is a constant value. With respect to omega t, we are integrating it. Okay, so don't consider that here two parameter is there. So we are put omega in your denominator. It is not like that. Okay, okay, it is a full term. Okay, beta. So now what is the value of IDC? So आपका IDC मिल गया. That is IM by pi. Okay. So why we are measuring these values? From this values, we are going to measure the efficiency of the rectifier. Then we are going to measure how much AC component, DC components are there. Okay. We are going to measure 5 to 6 parameters. Okay. So we are going to measure the 5 to 6 parameters. So you comes to know. Okay. So is it clear, right? How we are measuring the average load current? Beta?
Yes, ma'am.
Okay, shall I proceed? So now we have measured that DC current. Okay, already I told you output may not only DC, it has the AC component also. So next I am going to measure that AC component. Okay, so here the AC component is nothing but RMS. RMS is nothing but your root mean square. Okay, so RMS is nothing but your root mean square. So using this RMS value, we are going to measure the AC current. That is some of the AC component present in the output, right? So we are going to measure that component also. It is represented by IAC or it is represented by IRMS. Okay, it is represented by IRMS value. Okay, so why we are going for the root mean square is because some AC component is present in the output. Okay, so some AC components are present in the output. In order to find that one, we are going to calculate the RMS value. Okay, so generally the here I am not going to give all the derivation, the formulas for the RMS and all. Directly I will write the RMS ka formula. How to find RMS current is by means of using this formula. 1 by 2 pi integral of 0 to 2 pi I square L d omega t whole power 1 by 2. Okay, you just to remember the formula. If I give this explanation why going for RMS values and all, it will take another one class. Okay, so you have in order to measure the AC component, we are going for the RMS value. So RMS formula is 1 by 2 pi integral of 0 to 2 pi I square L into d omega of t whole power 1 by 2. So same procedure only. You know the value of IL. The IL is nothing but IL is nothing but IM into sine omega. Okay, you know that Im into sine omega t. You know that one. Okay, so Im is nothing but here. IL is nothing but Im into sine omega t. Its interval is 0 to pi. Okay, अभी क्या करने पड़ेगा? Just substitute that value here. So you will get 1 by 2 pi integral of 0 to pi. Okay, Im into that is square, right? So sine omega t. So I square omega sine square omega t into d omega t whole power 1 by 2. Okay, whole power 1 by 2. Okay, this is the formula. Okay, whole power 1 by 2. Okay, so anyone tell me the formula for sine square theta? In trigonometric you have studied how we can write the sine square theta.
1 minus cos square theta.
Okay, 1 minus cos 2 theta by 2. Okay, 1 minus cos 2 theta by 2. So अभी क्या करने पड़ेगा? Just substitute कर लीजिए. So 1 by 2 pi integral of 0 to pi. Okay, so I square m. So already I told you sine square theta can be write it as 1 minus cos 2 theta by 2. Okay, into d omega t whole power 1 by 2. Okay, whole power 1 by 2. Okay, so from this equation, and I know that the I square m is a constant value. You can take it outside. So 2 pi into 2 also I am taking common. Then integral of 0 to pi 1 minus cos 2 theta. Okay. Directly I can multiply this d omega t inside. So I will get the value of d omega t minus cos 2 theta. Sorry, not theta. So here I have given it is a theta. It is not a theta. It is a omega t. Okay. So here also it is omega t. Omega t into d omega t whole power 1 by 2. Okay, so just to perform the integration, so you will get the value of I square m by 2 into 2, I will get 4 pi. Okay, just to integrate the value, so d of omega t means I will get omega t. If I integrate the cos to omega t means I will get sine 2 omega t by 2. Now 2 will come in a denominator because I am integrating with respect to the omega t. So here the 2 is a constant value, it will come down. Okay, so now you have to apply the limit. So you know how to apply the limit, that is upper limit minus lower limit. So please apply that value. So you will get the final value. Okay. So I can write it here. That is I square m by 4 pi. Okay. Just substitute the value pi minus of sine 2 pi by 2 minus 0. Okay. Upper limit 0. So plus sine 2 anything into 0, 0 only I will get. Like this it will come whole power 1 by 2. So I will get I square m by 4 pi. Okay. So pi minus, so here sine 2 pi value is 0 only, minus 0 plus 0. Okay, power 1 by 2. Okay, power 1 by 2 I will get. So here it is whole power of 1 by 2. Okay, so I will get I square m by 4 pi into pi whole power 1 by 2. So pi pi cancel हो जाएंगी, आपका वैल्यू मिलेगी I square m by 4 whole power 1 by 2. So 1 by 2 means square and 1 by 2 cancel हो जाएंगी, आपका मिलेगी im by 4 का if you take square root of 4, that is nothing but 2. So the value of IRMS is equal to im by 2. Okay, so now we got that how much AC component in the output and how much DC component in the output. So next we are going to calculate other parameters like a ripple factor and all to calculate the percentage of AC component in the output. Okay, so almost time is over. In the next class I will continue with the remaining derivation. Beta, got it right? So please tell me.
Yes,
Yes,
ma'am.
ma'am.
Okay, so today what you guys need to do, please go through the about your off-air rectifier as well as this derivation part. Today I will share this one in your WhatsApp group. Please go through it and try to practice in your copy. Don't simply copy, you try to derive it. If you are having any doubt, in that case you just refer. Okay, beta? So time is almost over. In the next class I will continue the